All right, so my name's Adam Mansueto. I'm the founder and the director of WorkStrong Health Solutions. So we're a business that operates across Australia nationally, and we provide early intervention and injury prevention services. So our early intervention is on-site physio as well as injury prevention services. So today what we're going to be talking about is the prevention of musculoskeletal injuries in the workplace, or musculoskeletal disorders, some people like to call it, specifically with reference to pushing and pulling tasks. So this is part of a webinar series that we've been running this year, and we're up to, this is webinar number 3, pushing and pulling tasks. And the next one that we'll be doing is gripping and grasping tasks next month. We've already covered sitting, standing, kneeling, crawling, and reaching, and lifting, carrying, and putting down objects. If anybody wants to see any of those webinars, they're online in our YouTube link. I can send that to you at the end, or you can just go to our website, which is workstrong.com.au, and you'll see our YouTube channel in the top right-hand corner. Let's get started. So today what we're going to be going through is the impact of musculoskeletal disorders with reference to pushing and pulling tasks, the biomechanics of pushing versus pulling, the key injury risk factors and the common injuries, and how to reduce those injuries, and of course the correct pushing and pulling technique. So why are we interested in this? And that's because musculoskeletal disorders account for 60% of all serious workers' comp claims. So they're still the largest cause of workers' comp claims. 38% of these are due to body stressing, and the next 24% are due to falls, trips, and slips of a person. And then the rest are, being hit by a moving object or mental stress, vehicle collisions. And so body stressing, it's important to mention what is body stressing. It's just an oblique term that somebody's just come up with, but basically it's repetitive movements, awkward postures, and prolonged periods of stress that's on the body. If we look at body stressing, most of the parts of the body is the trunk. So the trunk includes the upper back and the lower back. And then the next largest cohort of those body stressing injuries comes from the upper limbs. So that includes the shoulder, the elbow, and the wrist. As we can see, 139,000 claims, serious workers' comp claims. This is 2024 statistics, which is the latest statistics from Safe Work Australia. And the median compensation claim is $14,000. And a median time lost of work is 7.2 weeks. So quite a substantial period of time that someone would be off work for an injury relating to body stressing. So we can see here that muscular stress while handling objects. So under body stressing, we have different categories. We've got muscular stress while handling objects. We've got muscular stress while lifting, carrying, and putting down objects. And then we've got stress with no objects being handled. And the final one is repetitive movement, low muscle loading. So these are your repetitive strain type injuries. So not a heavy load, but a lot of repetition, like picking. Not picking heavy objects, but just line picking, whereas we're interested in muscular stress while handling objects, because I've highlighted that because I think that most closely relates to pushing and pulling tasks. Of course, if it was somebody lifting an object, that's going to come under the next category. And so that makes up 25.5% of these body stressing injuries. It's also important to probably point out that when somebody does do pushing or pulling, they might actually sustain a fall. So they might slip while they're trying to push, or they might fall backwards while they're trying to pull something. And that might actually come under a fall on the same level. And that's 15.4% there. And so this figure actually of pushing and pulling tasks causing injuries might actually be higher than what we can see. Okay. So moving on to the biomechanics of pushing and pulling, just move that over there. What we have here is the formula for identifying how much force in newtons is required to push an object. So it's important to go through this to have an understanding of what we're talking about here and how to reduce injuries. So force, pushing force, equals U, which is the coefficient of friction, which is dimensionless, times mass times gravity. Okay, so the mass is the mass of the object that you're trying to move. Um, Gravity is a constant of 9.81 meters per second squared. And we've also got this friction here. So in this case, it would be the friction between the wheels and the floor. Okay, now the aim of why we're looking at this as well is because we want to identify what are the modifiable risk factors here that we can change. So we can't change gravity. That's going to be the same unless you want to look at this on the moon. But here it's going to be exactly the same. We can't change that. We can change friction. So this coefficient of friction you can change, and we're going to go through how you can do that. Um, and the mass, you can change the mass. So, you don't have to put 2, 3 boxes of, say, 50 kilos on all at the same time. You could put one box on it at a time and spread the load out over 3 different pushes, for example. Now, getting into the friction. So if we wanted to reduce the friction, you can't change the surface, as this will change the friction between the floor and the person, and therefore increase the risk of slipping. So if we turn around and say, hey, I've got a brilliant idea, let's make the floor really, really super smooth and polished. And that way there's going to be, the wheels are going to glide over the surface a lot easier. That's true, that would happen, and the friction would decrease between the wheels and the floor, but that'll also decrease the friction between the floor and the worker who's trying to, or the employee who's trying to push the object. So that's not really a good idea. What we can do though is we can improve the wheels. So you can improve the wheels and therefore reduce the coefficient of friction that way. Okay. Um, So this is a general look at musculoskeletal disorders and risk factors. And you've got on the left here in the green, you've got the task factors, and on the right-hand side, you've got the human factors or the individual person's factors. Excuse me. So if we look at the task factors, first of all, we've got the environment is one of the factors. So a hot environment or a cold environment. We've got physical requirements, so the load and the movement. And we've got the organizational environment, so space, time, pressure, team handling. It's probably important to note there that the friction falls under the load, and when we're pushing, a dolly or a cart, the distance, the speed at which we must go, and the frequency is also part of the task factors. Of course, part of the load as well is the weight and the size. Okay, so on the human factor side, we've got the fitness, the age, the level of training or the skill of the employee, um, particular clothing that they may need to wear. So for example, if it's a really cold environment, then they might have to wear thermal jackets, and that's going to cause some restriction in movement. And of course, the anthropometrics of the person. So the height, the weight, the size of the person as well has an impact. Now, looking a bit more specific to the risk factors with regards to pushing and pulling, it's exactly the same as what we've just seen here, but what we're doing is breaking it down. So we've got task factors on the left, we've got cart and equipment factors, and then we've got the ground and the floor and the ground factors. So the task factors, the distance moved, the movement initiation force to initially get the object going, the sustained motion force, so to keep the object moving, there needs to be a certain amount of force as well, the direction and the nature of the movement. And so if you need to change direction, that's also going to be a factor, and the duration. So how often or how long are you going to be doing this throughout the day? The cart equipment factors are the handhold height or the handle height, the caster or the wheel design, the type of wheels, the stability of the load, the size of the load, and the weight. So the size being, is it going to obstruct your view? Is it really large and therefore unstable? And the weight is just the actual mass. Now the floor or ground factors, so surface characteristics, are there a lot of divots or bumps on the surface, or is it reasonably smooth? The slope of the ground and any contaminants. So if there's debris or things that can go into the wheel and cause restriction to movement of the wheels, that would be another factor. And on the right, we've got the human factors there. So the first thing is when you're trying to reduce the risk of an injury from happening, we want to address these factors. Okay. Now, all of these factors on the left here are modifiable, and that's why engineering is the number one or the first step that you should focus on as much as you possibly can. And then there are some non-modifiable human factors like age, height, and weight, but we can improve other things like strength and technique. So they are modifiable factors. So first, what we're going to do is we're going to look at the task factors, and then we'll look at the human factors. Okay, so the first one is thinking about the casters or the wheels. Let's move that to the side. So the load distribution and force requirements. So the load of the wheel is divided amongst all the wheels. So if you've got 100 kilos and you've got 4 wheels, then each wheel is going to be taking 25 kilos of force. So when you're trying to design a dolly or a cart that's going to be pushed in your workplaces, you need to think about what's the total load that needs to be pushed, and then divide that by the number of wheels. And each wheel will have a wheel rating, and you'll be able to decide what's the best wheel or the most appropriate wheel or trolley. Um, the wheel radius is really, really important. So larger wheels in general will require less force to initiate the movement, and it'll handle bumps better. Okay, so as you can see in this image here on the right hand side, the larger the wheel radius, it handles bumps better since the angle of attack is reduced. So you've got this small little bump here in the ground. The larger the wheel, the angle of the attack is lower, and therefore it's easier to navigate. Whereas if you've got this smaller orange wheel, then the angle of attack is going to have to be high, and that's going to require more force that's needed in this direction to try and push over those bumps. So wheel radius is really important, larger wheels being better. The wheel tread material. So the material of the wheel tread has the greatest influence on mobility. So softer wheels handle debris better because they can overcome them, but harder wheels like solid elastomers, they offer better performance on smooth surfaces as they don't deform as much. The environment is really important. We need to consider the environment. So thinking about floor surface, the temperature, debris, or chemicals. So for example, urethane wheels are a popular choice for balancing load, surface adaptability, and chemical resistance. Sealed bearings are ideal for extreme temperatures or frequent wash downs. So if you're having to wash, if you're thinking about food production, then you need these sealed bearings. while debris-resistant materials or protective guards will help prevent rolling issues from swarf, which is fine bits of metal and other metal producing products from machining or contamination. So thinking about guards on the wheels. Okay, the next thing we need to think about in terms of the wheels is making sure that it's very, very rare that you're ever going to push a cart or a dolly in a completely just straight line. We're always going to need to change direction. And so that's when swivel casters are really important. So casters that swivel, they will allow a much lower level of resistance for turning. If they weren't able to turn, you'd have to try to force and push the trolley to one side and slide it along the floor. And that's going to be a lot more difficult when there's load. A mix of swivel and non-swivel, so rigid casters are the non-swiveling ones, they allow for the best option for the balance of stability and maneuverability, okay? And the best position to put the swivel wheels is under the handle. So as we can see here, these ones would be your swivel casters, and these ones here at the front would be rigid, okay? Um, and the reason for that is if it's directly underneath the handle, the swivel, then that's going to allow the less leverage, you're going to have more leverage, so less force is going to be needed to try to turn left or right. Now, the last thing to consider with regards to the casters or the wheels, well, it's not so much the casters or the wheels in this case, it's the load. So you want to position the load on the trolley so that the weight is over the rigid wheels. So what we're going to be doing is putting the weight, rather than distributing the weight evenly, if we have the option and it's not going to throw the trolley off, then we want to put the weight at the front underneath these rigid wheels. That'll make turning a lot easier, okay? If you don't need to do much turning and you're just going in a straight line, then sure, that's fine. We can distribute the load evenly on the trolley. Obviously, though, you wouldn't put the weight more on the left or the right side. It would be directly in the middle, just at the front. Okay, so the next thing that we need to consider when we're pushing or pulling um, an object is the height of the handle, if there is a handle, or the height of the hand placement. So research by Lin, Jung, and Huysmans, they've shown that the height and width of handles on carts affects the ability of the operators to exert force. So the maximum force that's achieved by an operator is when they exert force at about waist height. And so if we look at the 95% of the population, um, so looking at anthropometric data, we can look at who's in the top 95%, so who are the tallest people, and the bottom 5%, so who are the shortest people, and then work out where the waist level is. So we come up with 91 to 112 centimeters is the height that we should have for the range of pushing and pulling. Okay, so this is a fixed handle that's not height adjustable, but ideally you'd want one that is height adjustable that could adjust between 91 and 112 centimeters. Okay, which should equal to roughly waist level. So as we can see here, you know, waist level is roughly here, and that's the level of the handle in this case. Um, and we'll go into vertical handles next. So vertical handles is really useful because we can have the same handle and we can have somebody who's shorter and somebody who's taller using the same handle. And so the separation width of handles also affects force capability. So that's the distance between the handles. If you ideally you want to push with two hands, not one. So vertically orientated handles are commonly recommended because, as we mentioned, they're a good solution. However, it doesn't address the width issue. And so that's where V-shaped handles can actually come into effect. So V-shaped handles look like this down here. And this value of y, once again, if we're taking the 95% of the population, then the distance should be 30 to 46 centimeters. So you would have the handles down the bottom at 30 centimeters, and at the top, they would be 46 centimeters apart. And therefore, 95% of the people will then find it comfortable to put their hands vertically in the right space, but also width-wise along the x-axis, they would also have the right width when they're trying to push. Okay, um, so there's a reason. So a study by Boyer found that the vertical handles, all vertical handles in a V shape, they were preferred to all other types of handles by operators. And the reason why that's the case is because of what we call pronation and supination of the forearm. So this is the neutral position here of the forearm, this one here in the middle. Supination is rotating to the right or to the outside, and pronation is rotating to the inside. So the most comfortable or the neutral position for us is mid pronation supination. And therefore you can imagine that if you've got a handle that's a vertical handle, that would then fit nicely into the hand and you'll be able to grip that. Okay. And you can see here what pronation and supination looks like. Okay, so in that position there, we're in full supination. That's mid-pronation supination, so that's the normal position. And then we've got pronation, which is turning the hand all the way over. Okay, and so the interesting thing is most handles are horizontal, which forces us into this pronation position, when in fact the mid position is the best position to be in. Okay. So moving on to pushing versus pulling. So pushing is more preferred compared to pulling, and I'd say most OH&S managers understand that and know that. But we're going to go through the reasons why pushing is the preferred option. So number one is there's a reduced spinal load with pushing. So pushing places less comparative force on the spine, particularly the lumbar region, so the L5S1, which is the lowest disc that's on the spine in your lower back. So Lee in 1991 showed that pulling generates 2 to 3 times more disc pressure in your lower back than pushing. And the reason for that is it's using different muscles. So with pushing, there's a better use of your muscles. Pushing allows you to use your body weight and stronger muscle groups. So your legs and your core are used when you're trying to push and control the movement. Whereas when you're pulling, you're tending to use your arms, your shoulders, and your lower back, which are smaller and more injury prone muscle groups. It's not so much that those muscles are going to become injured. The shoulder tendons can sometimes become irritated, but it's mostly because when you're trying to pull, your back will round and that will increase pressure onto the discs, as Lee showed. Also with pushing, workers can maintain a neutral spine and an upright posture, whereas pulling tends to promote trunk twisting and backwards leaning, which increases the risk. If pulling while facing in the direction of travel, the arm is stretched behind the body, placing the shoulder and the back in a mechanically awkward posture. So if you've got your arm behind you because you're trying to look in the direction that you want to walk, then your arm is then going to be twisted and you're twisted through the spine as well. So one of the obvious ones as well is pushing has an enhanced visual field. You can see where you're going. Pushing keeps you facing in the forward direction. Pulling often requires walking backwards or side on, which limits your field of view. And what that does is number 6 down here, if you're more challenged in terms of the way you're looking, if you're facing forward while pushing, that's proactive hazard identification, whereas pulling can obscure the path or lead to a sudden loss of control if the load catches on something. And so there's a greater risk of you falling backwards and the load coming into you if you're pulling rather than pushing. So delving a little bit into that study with Lee, so pushing engages the abdominal muscles and the hip flexors to stabilize the trunk, whereas pulling engages your back muscles and it increases the spinal load due to trunk flexion. So as we're trying to pull backwards, if the load's not too heavy, you can probably keep your back straight. But if the load starts to get even a little bit slightly heavier, that's going to start to increase the pressure on the lower back. And as you can see, the back will start to round in this case that we can see here. And so, as we mentioned, there's 2 to 3 times greater pressure on the L5S1 disc compared to pushing. Um, Pulling increases the spinal compression. And so I'd say the number one reason why you'd rather push than pull, there's 2 reasons. The one is that you're not going to fall backwards and the load's going to hit you. And the second reason is this issue here with the lower back and the pressure on the L5S1 disc. So a bit of a recap. So your spine should have this nice S shape, okay? In between each of these bones are these blue discs. So this blue disc is this one here. We've got strong fibers on the outside, but on the inside is more of this kind of jelly substance. And this gel substance is there to make your disc squishy, to increase mobility and movement. Our spines are meant to flex and move. But what happens is if there's too much compressive force, so force pushing together, then this bulge can start to come backwards, as we can see here. So we've got a bit of a bulge coming backwards of this nucleus pulposus, which is the inside of the disc, and that's putting pressure on a nerve. So you'll hear different terms: disc herniation, disc prolapse, disc protrusion, bulging disc, herniated disc, slip disc. They actually all mean exactly the same thing, which is this phenomenon here of the nucleus pulposus pushing backwards and either putting pressure on the nerve or just causing back pain. And so here we can see the pushing versus pulling in effect. Pulling starts to round the back, which causes that bulging disc or that pressure on the disc. Whereas if we're pushing, we can keep the spine straight, and that's not going to affect the discs. So looking at the human factors now and trying to reduce the risk of an injury, we can apply the correct manual handling techniques. We can improve muscular strength and endurance. We can make sure that employees are warmed up, and we can maintain mobility and flexibility through muscles and joints through stretches and tissue releases. The first thing we're going to go through now is applying the correct manual handling technique. So what you want to do with manual handling task training is focus on each task as an independent task. Don't lump everything all together and try to do a training session or manual handling assessments just for everything. You've got to do it on a task or an individual basis. So the first step is you want to find the optimal technique that reduces awkward postures, that is reducing stress on the joints, muscles, and tendons. The second thing is you want to train the employees on this correct technique. And the third thing is you want to assess their technique. And if somebody is not competent, then you want to do some training with them to make sure that they get to the point that they are competent. So the question is, what is the optimal technique for pushing and pulling? We're going to go through that now. So the first thing is that we want to make sure that the head is in a neutral position and in line with the spine. And so that'll make sure that the spine is straight. And to do that, you want to make sure that the person is pulling their shoulders back and that their chest is up. And so we can see here that there's a straight line through the spine there. If we look at this image here of pushing a pig, we can see that there's a difference between where the head is positioned and where the back is. So that tells us that the spine is not straight, and that's not a good position to be in. We want the spine to be straight. So if we're drawing a straight line through the hip, the shoulder, and through the ear, we should be able to see that there's a straight line, and therefore the spine is straight. Now, in order to do that, you need to make sure that we're what's called hip hinging or hinging through the hip. So drive the hip backwards and bring the chest forward. So this is an exercise that we can use to train somebody. Another way that we can do it, here with this gentleman here, we're doing some practicing on how to hip hinge. So you can start from a seated position. And this is the same technique that you'd need for lifting. And so we're using a stick here. You can see the stick is there that's held along the back. I didn't draw a straight line that well. But the idea is that we're trying to keep a straight back by having 3 points of contact of the stick, one onto the back of the head, one between the shoulders, and the third one is on the sacrum, which is the tailbone. And so if you maintain those 3 points of contact with the stick, then we know we've got a straight spine, and we're going to be hinging through this hip joint at 90 degrees. Okay. And so when we're pushing, we would get to that position where we're in a hinged position, and then you put your arms up in that position and start to push. So hip hinging is a really important part of the pushing technique. One issue that we don't want to do is we don't want to be collapsing in through the lower back. So on the right here, we've got the correct technique. So we've got a straight spine and we're pushing forward. Here we're pushing, but we're leaning backwards. So this will happen when the load is too heavy, I guess. So if you do see this, I would be addressing other factors higher up on the chain of how you can reduce the load or reduce the resistance of the wheels or whatever you're pushing, because it would just be too forceful. So trying to avoid the back caving in, the core needs to be braced and the back remains straight. So if somebody's not using their core muscles and they're not holding their spine straight, this is what you might start to see. Next on the checklist is the trunk of the body should be leaning slightly forward if you're pushing or slightly backwards if you're pulling. And you'll be able to see that in the next slide. And your arms should be straight, but elbows not completely locked out. So we can see here that there's a really large bend in the elbow here. And on this right-hand side, it's just a very slight bend. And so this is incorrect, whereas on the right, this is the correct position. And you can see that with regards to the trunk, we're leaning a little bit more through the trunk here compared to here. So this is just a slight lean, whereas this one's a little bit more. You're going to get more force by leaning in forward and using your body weight. So next is the hands on the object should be at hip to waist level. We've mentioned that before with regards to handles. And when pulling, it should be waist to chest level. Waist to chest level when pushing and hip to waist level when pulling. So pulling is a lower level compared to pushing is at a higher level there. Okay. Um, so no twisting or turning of the body because that's going to twist the spine and increase the risk of a back injury. We want to squeeze the gluteal muscles, which are the bottom muscles in your legs or in the bottom, and use your legs to push or pull. So the force should be coming from the legs. And so it's important, this last step here, that feet should be shoulder width apart. So that's this distance from here to here. And one leg in front of the other. So that's that distance from there to there. And what that does is that creates a nice solid base of support, which is this area here. And that allows you to push and pull with lower risk of falling over or slipping. Okay. And so that's the end of the checklist for the correct technique. And you can apply this technique or this checklist to any pushing and pulling tasks. So in this case here, we've got in the transport and logistics business, we've got pulling curtains on trucks. And so we've got the same principles that apply with feet shoulder width apart, keeping the elbows close to the body when we're pulling between hip and waist level, and using our legs to pull rather than our arms. And the other thing to keep in mind or to mention is that the wrist should be straight and in a neutral fixed position. So especially when you're having to grip things that aren't like a handle, which are nice and easy to kind of grab hold on, something like grabbing the straps of this curtain, your wrist can tend to bend, but we've got to make sure that the wrist is completely straight. So it's not being bent through this area because that can cause wrist damage. So this is the full checklist here for pushing and the full checklist here for pulling. I've got a QR code at the end of today's webinar that you can scan and get this checklist. Um, So you can reduce the risk of individuals being injured. We've mentioned the technique of correct manual handling technique. The second thing that you can do is you can focus on improving muscular strength and endurance. So the first area you would look at is core strengthening. So strengthening the muscles of your core area of the trunk. That'll reduce the risk of a lower back injury, which is the number one injury that would tend to happen if you're doing pushing and pulling. So, and the second one is shoulder strengthening. The third would be strengthening up the glutes in your bottom and the legs, seeing as though they're the muscles that are the prime movers of completing the task. And so this will reduce one of those the 5 biomechanical factors, which is exertion. So the core are all the muscles that are deep in the abdominal area that help improve the stability of your spine. So your spine, as we mentioned before, is just a bunch of bones, individual bones that are called vertebrae that are joined together by the discs, and it's very flimsy and floppy, and it's supposed to, allow us to be able to bend and twist and move. But when we're having to push, pull, or move an object or lift an object, we want our spine to be braced and solid and not moving. And that happens through the muscles. And so your core muscles stabilize the spine by contracting and squeezing in, which will decrease the compression on the discs and stop the spine from moving around. Now, the main muscle to do that is transverse abdominis, which is this highlighted muscle here, which will start at the front, but will wrap around to your back area and connect all the way onto the back. So this muscle actually acts like a corset by squeezing in when it contracts. So a muscle will contract or shorten along its fibers, and in this case, the fibers are going transverse or across, and that's why it has this squeezing effect. Now, in terms of exercises, McGill came up with 3 key exercises for strengthening the core. So the first one being up here. This is number 1, so this is supine cycling. Number 2 is a side plank, and so obviously you do your right side, but then turn over and do the left side as well. And number 3 are these alternate extensions, or some people like to call it the bird dog exercise. And so these 3 muscles will strengthen the core, and they should be part of any core strengthening program. And so we've just got a few images here, just some real life case studies. So we can see here that we're in a pronated position, reaching above shoulder height, and then trying to pull. So this is not ideal. It would be better to use a double-handed grip like we've got in this case scenario. But once again, this is above shoulder height. It'd be better if this was lower. Thinking about your hands and the hand position, if we're grabbing 2 doors here, you're going to be in a position where you're at maximum grip, and we'll be going through this next webinar, but that's not an ideal position to be in. I can't get direct feedback from you guys, but there's actually nothing wrong with this image here. So it's a bit of a trick one. But this one here, we can see that the handle on this tub is just too low. And this is an ongoing issue in the meat industry that we're working on trying to solve. It's a very difficult challenge. Okay, so I'll stop sharing the screen here. I'll just leave it on. So the last thing I just wanted to mention, sorry, is if you're trying to reduce musculoskeletal injuries in the workplace, thinking about at this point, what are the next steps that you should do? So the first thing you should do, and this is the correct order, is number 1, you should be performing some manual handling risk assessments to try to identify which tasks are causing the most stress or strain on your employees. The second thing is to have some kind of early intervention program in place. So an example of that is on-site physiotherapy. Unfortunately, no matter how hard we try, there's still stress on the bodies with tasks, even though we try to, prevent as many injuries as possible. And that'll help, manage injuries that you have before they turn into more serious injuries. And it also helps give you some leading indicator information. So if you promote your staff to see the on-site physio before something gets worse, then they can give you some information about which tasks seem to be causing stress on the body. Because, as much as you have hazard identification, sometimes employees don't report it. And the third thing is implementing injury prevention programs. So as we've just mentioned, manual handling training and assessments, but also pre-employment screening, warm-up programs, ergonomic assessments, and strength and conditioning programs. So I'll leave this screen up here, but I'm just going to have a look at the chat to see if there's any questions. Okay. So feel free, guys, if you've got a question that you want to put um, into the chat. Okay, we don't have any questions at the moment. I'll pop my email address in here. So if anybody does have any questions, um, our team will be able to have a look at those questions and we'll get back to you. Should I recommend a squat lift as a technique rather than a deadlift? Okay. So we covered this in our previous webinar. It does depend on the object that you're trying to lift. So in a squat technique, basically the trunk or the body is going to be a bit more vertical. So if you're trying to lift something that for example, is like a piece of glass that needs to remain vertical, then the squat technique is going to be preferred. If it's just a tub, then it doesn't actually matter if it's the squat technique or the deadlift technique. The deadlift technique is somebody's going to be leaning a bit more further over. In both circumstances, the spine, if it's done correctly, the spine will be straight. And so it depends on the personal preference of the person. If it's not an object that doesn't need to be kept vertical like a sheet of glass. I hope that answers your question, Nigel. Okay. All right, guys. Well, oh yes, we have another question. Are there some workplaces you find where pulling pallet jacks occurs rather than pushing? And if so, strategies to counteract this. So the way to counteract that would actually be to have an automated pallet jack rather than a manual pallet jack. So then it doesn't matter if you need to push or pull, it's going to be easy and it's not going to place too much strain on the body. If it is going to be a manual pallet jack, and there are places and workplaces that just don't have the capital at that point in time to go for an automated one, that's when it tends to happen rather than pushing. So the strategy would still be that you try and push and you just make sure that the weight, so thinking about the servicing of the pallet jack, make sure that the wheels are serviced well and they're well lubricated to reduce any of that extra friction. The training that we've spoken about, so getting people to only pull to maneuver into a certain position, but then push as often as you can. There's always going to be some element of pulling because you need to move around spaces. But as soon as you can, if it's going to be over a longer distance, you want to then push rather than pull. Someone's made a comment, make sure you park facing the direction of travel. Yeah, that's correct, Nigel. Yep, so Nigel's just pointed out to make sure that you park facing the direction of travel. Yep, so what Nigel's saying is move the pallet jack into the position that you are going to travel in. So that's before you put the load on. And then when you put the load on, then you're ready to then push in that direction. And so you're pushing with the load and only pulling without the load on. Okay. Thanks for your time today, guys. I hope it's been helpful. If you do have any further questions, you can email me through info@workstrong.com.au. And also don't forget to get that checklist. You can just scan the QR code. And the other thing is, if you do have any further questions and you want to um, jump on a free discovery call, then just scan the QR code and you can book in a session with me and we can have a chat about how we can solve the problems at your workplace. All right. Thanks, guys.